All right, good day everybody. This is Jason Strike with the Cloud Pass Virtual Group. Our presentation today is Designing for Azure Data Warehouse Performance, and our presenter is Beth Wolfset. In just a couple minutes, I'll pass things over to Beth so that she can begin her presentation. But before I do that, I just have a couple announcements that I want to run through. First, as you guys hear time and again, we do have a lot of sessions coming up. There's about 2 every week going now through the middle of September, and a few scheduled out for October. So if you're looking for anything Azure related, I think I'm touching on pretty much most of the topics with some of the presenters that we have coming in. So do take a look at that and get registered so you don't miss out on any of these. If you are interested in presenting, there is always room on the calendar. Right now we've got 2 per week that we have planned. So there's plenty of room at the end of that list of current presenters for additional presenters. So if you are interested, please reach out at cloud@pass.org. Alternatively, you can go out to the form that I have out on cloud.pass.org and just click on the call for speakers. Click on that, fill out the form, and I'll work with you to get you scheduled onto our calendar. Coming up this fall is Pass Summit 2019, and just recently they announced all the sessions for the community call for speakers. So there's now over 200 sessions that are listed out there that you can go and take a look at to see what's coming up at the Pass Summit. Excuse me. To see if some of those sessions appeal to you, and hopefully many of them will, and you'll go and get registered and be one of the many attendees for the Pass Summit 2019. Additional to this year is a Pass Summit All Access, and that gives you the opportunity to get some exclusive access to some of the content. So go and check that out. You can go to Pass Summit 2019 Summit All Access. If you have not registered for the Pass Summit and you are planning to do so, you can get a discount on that through this virtual group. Just fill out your registration, and then at the point where you get the option, just enter the code VGDIS FKDQ, and it'll get you a $150 discount on your registration. This virtual group is part of a large number of virtual groups that Pass helps to support. These virtual groups tie into different aspects of the Microsoft Data Platform. Some of them focus on language to help folks that are maybe not too fluent in English to learn in a native language, and so there's Global Hebrew, Global Spanish, and then there's also ones that focus on specific job roles such as data science and DBA fundamentals. So there's lots of presentations that are going on all the time, and most, if not all, or if not all, many, probably all, are being shared out to Pass TV after the session, so you can go and check them out there if you miss anything. Throughout this presentation, you may have some questions for Beth regarding Azure Data Warehouse. If you do, just open up the question panel that is in the GoToMeeting or GoToWebinar, and it'll give you an opportunity to submit your questions. Submit those questions and throughout, and at the end we'll go through those and see if we can answer as many as possible in the time that is permitted. So with that, those are the announcements that we have for this week or for this session. So our presentation today is Designing for Azure Data Warehouse Performance with our presenter Beth Wolfset, and I'm going to now make her the presenter. All right, there you go.
Thank you, Jason. Let me make sure I can share the screen here. Okay.
It's shared and I see the presentation.
Get into presentation mode. Okay. So thank you very much, everybody who is joining me today. My name is Beth Wolfset. I am a senior data architect for Insight Digital Solutions. And I have been working with data for more than 25 years. I was working with a client for the last few years, and we were using the Azure Data Warehouse. And as we did that, we had some issues that came up and things we had to solve, and that's when I put this presentation together. I have given it at a number of SQL Saturdays in the Northeast area, but this is my first opportunity to give it to a wider audience. So thank you for joining me. The slide deck for this presentation is in my GitHub directory, which you can see from the presentation right now. So why are we here talking about, oops, it's not moving to the next screen. Okay, so why are we talking about Azure Data Warehouse and why is that important versus Azure SQL Database? So I like to use this analogy. If you are familiar with the languages of Portuguese, Italian, and Spanish, you know that those languages are very similar. Frequently, a person who speaks one of those can at least understand another one of those languages. So on the bottom, I have a statement, el diseño de la tabla de la base de datos tiene un impacto en su desempeño. Sorry if I pronounced that poorly. Now, in general, if you didn't know what that meant and you put it through the Google Translate or another translating application, you will get a translation something like to the right. The design of the table of the base of data has an impact on the performance. And of course, that is not really what we want to say in English. In English, we want to say the database table design has an impact on performance. So in a very similar way, you have a number of databases that speak SQL, for example, SQL Server, Microsoft Access, and Azure SQL Database. However, what's happening under the covers needs to be translated a little differently, and that's what we want to talk about today. What do you have to be aware of when using Azure Data Warehouse? I am not going to spend a lot of time explaining what Azure Data Warehouse is or the details of it, but in order to give you that kind of reference, I have listed a number of resources here. And some of them talk about how to install the database, how to get started with it, but I'm going to assume that most of the people who've tuned in today have already been using it and know what some of the issues are. The one thing I do like to remind people is Azure Data Warehouse, as well as a number of products on Azure, are fairly new and they're in the cloud, which allows them to change frequently. So here we are giving this presentation on August 1st of 2019, and I guarantee you that within a week, a month, or a few months, some of what I'm about to tell you may have changed. And that's okay, you just need to know where to get the current documentation. Okay, so let's take a few seconds to talk about the actual architecture. Azure Data Warehouse is a massively parallel database, and it starts with a control node. Each version only has one control node, and that's sort of directing all the traffic. Now, depending on what level of the database you're using, and true with all the other products in the cloud, you choose what level you want to operate at. You may have one or more compute nodes. So I'm showing 2 compute nodes here. And those are dealing with some of the work of the database queries that cannot be done directly. And then you'll notice there's a lot of storage nodes. In fact, there are 60 storage nodes. And the data is being stored on the storage nodes. And so that is what makes this massively parallel. The data is across the 60 nodes, and then you're using one or more compute nodes to access that data, process the query, and return it back to the user. Now, I want to take a little bit of a look back. Some of us remember using SQL Server linked servers. Or more likely, you remember your DBA hating the suggestion that you would use SQL Server link servers. The idea behind the link server was that you could have multiple DBMSs, and you would use the link server definition to be able to talk to those from a single instance. You could have been doing this with multiple instances of SQL Server, or you could have done this with other DBMSs. Now, this notion hasn't gone away all that much. It's still pretty much the concept that's in use when you talk about elastic query, which is the ability of Azure SQL to query across multiple Azure SQL databases using coming from one database, what I like to call the driving database. Now, why am I bringing this up? Because when I look at the architecture from Azure Data Warehouse, and I look with, and this diagram is from the Microsoft documentation, the one on the right, and I look at the diagram for the SQL Server link servers, you see the commonality of having certain servers having to talk to multiple places where data is stored. And that's kind of the crux of what's happening underneath the covers of Azure Data Warehouse, and why we have to be aware of how we are storing the data in order to make the best out of this massively parallel system. So a couple of other things we want to go over quickly before we jump into the meat of the topic is the types of the distribution of the tables in Azure Data Warehouse. There are essentially two ways to store tables. One is distributed and one is replicated. Distributed, as the name will imply, means across the various nodes, and replicated means a copy of each table is stored on every node. Now, within the choice of using distributed, you can choose to use a hash value to distribute the data, or round robin. Round robin means Microsoft is deciding, and they're essentially going to load balance as the data comes in, what goes on each node. You'll notice that there are some basic guidelines of what types of tables might make sense. So for example, we talk about fact tables would be usually are best served by being distributed using a hash column or rapidly changing dimensions, whereas a round robin table might be is used a lot of times when you're loading data. And your dimensions, if you're in a relational database, your dimensions, which are usually smaller and static, are usually best served by replicating them so the data you need for each query is on every single node. If you have bridge tables in your data model, it may turn out that you can store them, and I'll say the word bridge, translation, mapping table, crosswalk, right? Different verticals tend to call these tables different things. Sometimes they will be small enough to be replicated, but sometimes you have to come up with a way to hash them and hash distribute them to align with the fact tables. So here's an example of a subset of the architecture. And we're going to take an example of purchase order. So we have an order ID and we have the month or year that it was purchased. Now, if I distribute this across the nodes, you'll notice that this way I'm doing the months are crossing the nodes. And so I have multiple values across months and across nodes. Now, you can partition. Hashing and partitioning are different. Partitioning is your traditional sense of SQL Server partitioning. So a lot of times you'd have very large data and you might partition on month and year, and that's what the blue line is showing here, that I could have a partition for March of 2018 and April of 2018. However, what's more important is to pay attention to the hashing. And what's going to happen with the hashing is you have to keep track of how am I going to join data together in order to decide what's the best way to distribute that data. The other thing that's important to keep in mind are your index options with Azure Data Warehouse. So Azure Data Warehouse supports your traditional row store indexes, heap, which is the one we all know and love for many, many years, and the clustered index. Keep in mind that the clustered index is storing data in the order of the cluster on the table. Now we introduce the clustered column store index. The clustered column store index is essentially a column store index storing the data in the columns in order, but by a column store, meaning you have the primary key and then the pieces of information tied very tightly together. So very much like a column store database, it's much easier to access pieces of that information. Now, the documentation will tell you that you should not use a clustered column store index unless you have 60 million rows or more of data in that table. And that's the preferred and optimized way to use the index. But in practice, we have found that it will help the performance when there's more than 600,000 or 1 million rows in that table. In other words, enough that there's enough data that makes the generating the clustered column store index helpful, and those indexes are in memory. What is very important, as in all SQL performance, what is very important is not just to have the right indexes, but to generate statistics and to maintain your index health. Now, this becomes more important in Azure Data Warehouse than perhaps other SQL databases. In other words, if you're inserting a lot of data, your clustered column store index will get kind of stagnant. It's going to put that data into the clustered column store index in batches. And if the batches, after a while, what you really need is to rebuild the index. So we end up doing a lot of rebuilding indexes and updating statistics. And I'm going to state here that don't ignore when you create temp tables in your stored procedures. Even there, we would put indexes on the temp tables and create statistics in order to get the best performance out of the system. Okay, now when I do this presentation in front of people, I actually play a little LMFAO of every day I'm shuffling, and I do a little shuffle dance because I want everyone to remember that shuffling is bad in Azure Data Warehouse. So I have a every day I'm shuffling. We get memory, don't be mad, now stop, data movement is bad. So the notion in Azure Data Warehouse is called data movement, but shuffling is the most common piece of data movement. And if you see a lot of shuffling in your database when you're looking at the query plans, you have to start tuning. So we're going to talk about the data movement, and then I think we get into actually taking a look at the databases. The first type, as I mentioned, is called shuffle. What you'll notice, the top section of each description is saying what's happening. So when you shuffle, you're taking a table that was distributed and you're applying a new hash algorithm and redistributing it. So basically, there's a lot of temporary data movement and table work going around when you're doing data movement. So a shuffle means that it's decided that it needs to change the distribution column in order to prepare for the join. Another data movement methodology is broadcast. In this case, it's taking a table that's distributed and replicating it across the nodes. We have partition, which is taking a distributed table and pushing it to the control node. This is usually done when you're doing aggregations, queries that do aggregations in it. You can have a trim, which is taking a replicated table and making it a distributed table. And you could have round robin, which is making a round robin distributed table, which you normally use when you're doing data loading. And finally, you can actually have data that's sitting in the control node and being replicated. So these are different movements. You'll note at the bottom of some of these slides that I have links. Some of these links are to presentations that I had in the resources page. So I like to give credit for the people who came up with some of these graphics. Okay, so we're going to take a look at what does shuffling look from an architecture perspective. We have our compute nodes A and B, and we have, in this case, some few storage devices. And the shuffling now is the red line. It's saying for whatever query you just executed, the data that was on node 1 needs to be combined with the data on node 3, 4, and 6. And so I shuffle the data from node 1 in order to do that. All right, so I've gone over a few things, and I like to say there's a number of considerations, but is your data parallelized or parallelized? And what we want to do is get to the parallelized part of the system. So I'm going to hopefully switch over here to my screen. Let me stop the slideshow. Let's see how to display this. Here we are. Okay, let me figure out how to tell it which screen to do. Okay. Okay. Sorry, I have a few people in the room with me so that I can speak to people and not just a computer, and they can't see the screen, but hopefully everybody else can. So the first thing I'm showing you is I'm in the Azure Portal. Hopefully this is not new to anybody to be in the Azure Portal. It is Azure Data Warehouse, so obviously you're going to create your database and get access to it through the Azure Portal. We have your traditional overview of the system. You have activity logs. If you've used Azure SQL database, you know that you most likely have to create firewall rules as you go from location to location. So all of that works the same. One of the things you can do is execute a query from here. I did not set that up, so if we have time, we'll try to do it. Otherwise, but you can execute a query from the Azure portal. When you go to create an Azure Data Warehouse database, you can create a demo database based on AdventureWorks, of course, using Azure Demo, and that's what I'm going to show you today. Of course, this isn't very exciting to look at it this way, so I'm going to open it up in SSMS. Hopefully everybody can see the left-hand side of the screen. Now you might be a little confused because you're going to see that on my local machine I have a copy of AdventureWorks Data Warehouse, but I also have the actual database that I've created in Azure Data Warehouse. Why did I do this? SSMS is constantly being improved to support Azure Data Warehouse. That's a very important thing to know because if you're on an older version of SSMS and you want to use Azure Data Warehouse, upgrade to whatever is the most recent. I believe I'm on 18.1 right now. But what you'll notice is you do not have the database diagrams feature when you're talking directly to the database. And of course, I'm a data modeler. I love to look at database diagrams. And I think this is important when you're using Azure Data Warehouse to understand the nature of your tables. So what I have done is downloaded a version of AdventureWorks Azure Data Warehouse for a local machine in order to do these diagrams. But if you're looking at your own database, what I would recommend is you would go into SSMS and use the tasks to generate the DDL for your Azure Data Warehouse database, and then you can import that into a local database so you can use that data modeling tool or any other data modeling tool you like. Okay, so what I have done is, let me show the diagram. Okay, it's showing now. This is one of the diagrams I did just by taking that data model that I downloaded and bringing it into Azure Data Warehouse. We have a concept of a fact table, product inventory. We have a product dimension and a date dimension that is very normal. However, when you look at your database that's in Azure Data Warehouse, somebody may or may not have categorized the table as dimensions or fact tables. So one of the ways to do that is to figure it out by using the data modeling tool. What I've done here, let's see if I can get this one to open up. There it is. Okay. What I've done here is I've brought in pretty much the same diagram. I'm going to scroll to the bottom and you're going to see my fact table is at the bottom. So a lot of people draw their data models for warehouses as sort of spoke and wheel diagrams, meaning the fact table is in the middle and the dimensions are circling around it. I prefer to draw my data model diagrams in what is called live crow notation. Now the reason it's called live crow notation is if you're using IE notation where you would get a crow's foot going to the many end of the relationship, then what's going to happen is the crow's foot's going to be pointing down because the crow is alive and walking, and your independent tables are at the top of your diagram and your dependent tables are at the bottom. That means your fact tables are going to be at the bottom of your diagram. What this allows you to do is figure out from a data model you didn't know anything about what is the hierarchy of the tables, and that is going to help you figure out which tables should be replicated and which tables should be distributed. So your dimension tables are likely going to be replicated unless they get really big. And the way they get really big, and this is going to happen to all of you, is your rapidly changing dimension. So in this data model we're looking at, we have a product key, a data key, and a number of other pieces. But if I was actually looking at an order, which I'm not here, I thought I had one ready to go, sorry. If I was looking at an order, I would have a customer ID. And when you have the customer ID, the customer is likely a dimension based on the Kimball definition, but it's a dimension that's changing all the time, meaning we get new customers all the time. At least I hope so for all of your business's sake. And because of that, the table gets quite large. And a rapidly changing dimension likely has to be hashed, distributed using a hash function rather than replicated. Okay, so given that, we're going to switch back out of these pictures to some actual queries. That was the picture. Okay, let me close the pictures. Oops. I'm looking for, not this one. Oh, here's what I'm doing wrong. Okay. Sorry. One of these is supposed to have a lot of queries in them, and I'm trying to figure out which one. Not that one, so it has to be this one. Oh, okay, I see what happened. Cut and paste in the wrong place. Okay, sorry about that. Okay, so here's your basic queries that you would do against a database. This is a list of tables. I can query that. Apparently I can't query that. Not sure why. Let's see. Reference to database or data name. Oh, sorry. That was off my local database. So true to form for any Azure database, we can't have the database name in the query, but now I should be able to do the same query. interesting. It thinks it has no tables. We'll ignore that for now. What I want to do is show you that I can query traditionally, but you'll notice I'm using an option called label. And I don't know if anybody has used that option yet, but I strongly suggest you get all of your developers to use that when you're using Azure Database. The reason for that, and you'll see in a second, is when you're looking at what's actually running, because the same query is being parallelized, you have multiples of it running, and it can get very difficult to figure out who is running what. But if you're putting the labels on it, it gets much easier. So let's take a look at that. This query that I'm showing you now is in the slide deck. I think it's underneath the last slide I looked at. So what I'm going to do is execute this. And what you're seeing now is a QID and an so a QID for the request and the session ID. For a given request in the Azure Data Warehouse, you could have multiple sessions. We have your traditional status. You have a submit time, a start time, and an end time. Now, why are there 3 times? Because the time you submit the request may not be when it kicks off. Remember that you're in the cloud and you are limited by your resources. And if you're trying to understand what those resources limits are, they're in the Microsoft documentation. Based on the level that you set, it will tell you how many compute nodes you're getting, how many distributions you can get per compute node, and how much memory you're limited to. If you get beyond that limit, it holds that query in queue. The problem is it may hold the query in queue a lot longer than you're used to, and so the start time will tell you when the query actually started. Mine, of course, are starting at pretty much the same time. You have a total elapsed time, and but here's what I was talking about before. You can see the label, which is, this tells me that that was the query I ran. I labeled it query product category. If you look at the commands, this is where you will see that it could be very difficult to figure out what's actually running because the commands are at a lower level and it's hard to see where your query is actually running. Although I have used this monitor request query and filtered for specific things in the command column to, say, find queries going into a specific table. The other thing you'll notice is you have a login name, and this is a place where I recommend, if you're having multiple users and even coming from multiple environments, querying your same Azure Data Warehouse, give them different logins because that allows you to kind of figure out what's coming from what system. Okay. Once you have looked at this, you can see there are some IDs that are in common. If I looked at 221, I'm going to change my query slightly here and put in 221. Now I can see everything being executed by the same session. Okay. So that helps you understand what's running by changing this request status. Right now I'm showing you everything, but you could change the request status to show what is not in completed, failed, canceled. And basically you could keep an eye on what queries are long-running queries. That obviously is a place to start tuning. The other place I'd like to go is this query here. The query is quite lengthy. What I normally do is take this query and make it a view, and then I can just query the view easily when I want to run it. But what I'm showing you here is that I have a table. It's telling you how it's distributed. It's hash distributed, what the distribution column is, and what the index type is. It's also telling you the number of rows in the table. You can go a step further and understand how much of the data is on each one of the 60 nodes. We call that skew. So let's talk about a couple of things we want to do here. Each one of these has likely been hashed on the primary key. There didn't used to be primary keys in Azure Data Warehouse, but you could always create an index on what you believe should be the primary key column. However, primary keys are supported. Foreign keys are also now supported. They weren't supported when I first used this, but you do have to determine if you really want to use those kinds of constraints, because they could really slow down your insert performance when using the product. Alternatively, you can just make sure that you've enforced that correctly, because after all, you're going to be using some kind of ETL or Polybase to load Azure Data Warehouse. You're not going to have transactional applications writing to it. It's not meant for that. The interesting thing here, though, is what I want to be able to do is if these tables are hashed, see none of them are replicated, I would need to make sure that the tables that need to be joined together are somehow ending up on the same node. And the way to do that is to use the same hash key. Now currently, I keep waiting for this one to change, but currently you can only hash on a single column in Azure Data Warehouse. I would hope eventually you'll be able to hash on multiple columns, like a composite hash, like you would have a composite index. And I would also hope that at some point you can influence the hash algorithm, but today you can't. So once you hash on the hash column, the data is spread based on that. So the way to make sure that the data for a join is on the same node would be to have a common column between the tables. So for example, we were looking at purchase orders before. No, we were looking at product and product inventory and orders. So if I wanted to be able to quickly understand how many orders I had for a product, how much was left in inventory, I would want to have I would want to be hashed on, say, the product key. So if I have several tables hashed on the product key, then I know that all the data for that product will be on the same node. Now let's say I was really trying to keep track of the inventory in each one of my stores. Now I might choose to hash on the store. The product table itself is likely distributed, but then I'd have to make sure that the store ID was also in my product inventory table as well as in my product order table. So what that means is that sometimes you're going to break your traditional relational model, which said don't replicate data that you don't need in multiple places, and push down those keys into the children tables, even though traditionally they weren't needed. And then you'll put the hash key on that. Now, in spite of doing that, you may find that your data is not evenly distributed across the 60 nodes. We call that skew. If your data is skewed, it will mean that the compute nodes dealing with the storage devices that have a lot of data may take longer to come back than the compute nodes dealing where the data is of lesser volume. It's not going to hurt the output. It just means the query is going to take a little longer because you didn't get it as balanced as you can. However, depending on your data, you might not be able to do anything about skew. So for example, let's say that your company merged with another company, because that happens all the time, and you have distributed on the store ID, but one store is in New York City and it does a phenomenal amount of business. Maybe it does 25% of your business based on some of your stores in other states in the middle of the country. At that point, you're not going to have a lot of selection on what else you can hash on. You could choose a different column. You can try to create a composite, and essentially create a derived column that joins in data from more than one column in order to do your hashing. But if you do that, if you create that composite column, you have to create it on the parent table and the derived column on the parent and all the children tables. So you may decide it's not worth that effort. You'll just deal with the skew. So we've talked about the distribution. We've talked about skew. Now indexing. You can still index the way you've traditionally indexed on SQL Server databases. But what is important is you will likely find that you need to put an index on the hash column. You want to believe in your head that it's implicitly indexed, but it's not necessarily indexed on each node. It was just used to distribute the data. So you'll want an index on your hash column, but more importantly, when you query, you will want to somehow include that hash column in your query. So again, this may be something that you say, I don't really need that piece of information in my query, but you force it in there. The reason is it's essentially giving an implicit hint to Azure Data Warehouse to know that it can do the query on the hash column, and then it is able to do it in parallel. So we saw a lot of improvement to queries simply by making sure that the hash column was in the query, even if it wasn't really needed, even if you knew that the store was always, if you're joining on two stores, we'd force that in and it would help. Okay. I want to go back to, I think I've showed enough of these slides. I want to go back to the PowerPoint presentation, assuming I can do that. Click to start screen sharing. I'm trying to. How come I can't tell it which screen to share? Okay, maybe we're not going back to the PowerPoint presentation. Some of the things that I mentioned in the presentation, we talked about the table type, the distribution, storage, indexing, partitioning, and skew. Those are all design considerations. I want to talk briefly about some performance considerations. I mentioned statistics. Keep updating your statistics on the system. Keep updating your index quality. When you use Azure Data Warehouse, there are different resource group levels. Let's see what they're calling them. For work mode management, traditionally, you're going to have, I think out of the box, it comes with 4 or 5 resource classes, a medium and a small. What you're going to want is your average users are using those medium and small resource classes. Maybe your ETL is using the medium resource class. However, when you go to rebuild your indexes, you're going to want them to use a larger and extra large resource class. Now what happens is when you use the large resource class, it's going to take a lot more of your resources. We had it set up to take 70% of our resources, so we didn't want to do it when a lot of people were on the system. But it gives that class more memory, and that makes the rebuild of the indexes not only faster but more efficient, because it needs to bring that into memory in order to build that correctly. So don't ignore paying attention to your resource classes when you're tuning for performance. We've talked about the data movement, and we've talked about using the statistics to improve the distribution to improve the data movement. The traditional SQL query plan in SSMS does not really give you a lot of information about what type of data movement is happening, but if you do the query plan through the Azure Portal, you can get actually quite a lot of information, including it'll actually show you what the temporary table that it created when it did the data movement looks like, what columns are in there and what it chose to distribute on. We talked about including the hash key in the query. And then before I stop talking, I want to express the importance of understanding how views, CTEs, and functions, as well as stored procedures, are working in Azure Data Warehouse. Any operation that you are doing in memory, if you don't use that memory efficiently, will take a long time. We actually have found that it was inefficient to use views in most of our work. Instead, we changed a lot of what was in views to stored procedures. And on top of that, if we needed to create a temporary space for, say, a CTE, we got rid of the CTE and we created a temporary table. Not an in-memory table, a real temporary table, potentially with an index and statistics on it, and then did the work in the stored procedure. The reason for this is when you create the temporary table, it's going to do it on your compute node or perhaps even on your storage node. But when you're asking it to do everything in memory, it's definitely bringing up to the compute node or the control node. So you're using features to keep the processing as close to the data as possible. So that's why I mentioned be careful of views, CTEs, and functions. Now, when you load data, it's a little bit counterintuitive. Most people load data into Azure Data Warehouse using Polybase. Polybase creates an external table, which is going to be a hashed round-robin table by definition. Now, if you try to take the data from the hashed round-robin table and push it directly into your distributed table, you will get a lot of shuffling. So if you read the data loading best practices, they're going to tell you to create an interim table just to push the data to the main table, and you're going to think to yourself, why am I doing that? But the reason you're doing that is the interim table you're going to create is going to take that data you just pulled in through Polybase and distribute it across the nodes in the same distribution as your fact tables. And then you're going to be able to go from the temp table into the fact table very quickly because the data is on the same node. If you don't do it that way, if you leave the external table as a distributed table by round robin and your fact table is distributed by hash, implicitly what Azure Data Warehouse is doing is bringing your entire fact table over to where your round robin external data is in order to do the compare. So it's extremely inefficient to bring the large fact table over. By creating the temporary table in the middle, you've purposely told it where the small amount of data and where to place it in order to do the compare. So that is the highlights of what I have for my presentation. I don't know if anybody has any questions.
Yes, we got a few questions here.
Okay.
And so let me just run through them. And one person was asking about database diagrams being gone in version 18 and onwards of SSMS.
So I don't find that to be true because the version I'm showing you of SSMS is version 18. I can prove that. I'm on 18.1. Okay. I don't know if Microsoft is continuing to develop the database version tool or not. It's gotten more robust. The feeling was they might have needed that to help people meet their governance guidelines that were needed under GDPR. I don't know if that's true or not. It is not as robust as other data modeling tools.
Yeah, I think it was removed for version 18, and I think they put it back in for version 18.1.
Okay.
I think I read some of that. And then there were a couple of people asking about those metadata scripts that you had and if they're available somewhere for download.
Yes. So the one I was using that I'm showing now to monitor for the queries is in the PowerPoint presentation. I will take this other one that gives you the sizing on the tables and I'll also add one for SKU. I'll add that also to the PowerPoint presentation, so all three of them will be there if you download the slides.
Sounds great. And just to reiterate, previously you had said that the slides are available from your GitHub location, correct?
They are. I don't know why I can't seem to get back to my PowerPoint presentation here, but I know a way to force it. It won't be as big, but okay, let me make this larger. Oh, sorry. Okay, I don't know if people can read that. But essentially, I am BS Wolfset. That's my GitHub repo, and the sub-repo is presentation slide decks. It is called Azure Data Warehouse Performance. I do have other presentations that I've given that I've been uploading there, so feel free to poke around. And if you have any questions, you can reach me on either of these two emails.
All right. And then question is, you said that primary and foreign keys are now supported. Is that true?
Yes, this was one of those fun things. I originally gave this presentation in January of this year as part of Azure Data Fest in Boston. When I gave it again in April as part of Global Azure Bootcamp Day, I think that was called, I opened up my page. So there used to be a location in the Microsoft that I had nicknamed what Azure Data Warehouse does not support. Of course, when I went and I clicked on that page to show everybody during the presentation, and what showed up was foreign keys were now supported. However, keep in mind that to enforce a foreign key, it's going to look at the data in your fact table and compare it to the table that the foreign key is to. If that foreign key is to data in another fact table and that data is not on the same node as the one you started with, it's really going to start a lot of data shuffling in order to enforce the foreign key. So my advice would be either don't use foreign keys. Yes, I am a data modeler who says you don't need to use foreign keys in the data warehouse, or only use foreign keys on tables that you have replicated.
All right. And the last question that we have here in the queue is, once you have all the data in your Azure Data Warehouse, is there a version of SQL reporting services that comes with it, or do you need to switch to Power BI?
That's a good question. I know you can use Power BI to go against it. I don't believe you can use SSRS unless you have installed that on an, no, I take that back. You could use on-prem SSRS, or you could use SSRS in a VM, because you just need the connection string, and it's just a traditional connection string. I'm showing that in the window right now. It's just a traditional Azure detection string.
Okay. And another question we have here is, does the latest version support extended properties?
I do not know the answer to that question, but if we can take a note of who's asking that, I can certainly investigate and get back to them.
Okay. And then an additional question is, what about the print statement? This used to be not supported.
I don't know if that's supported. We can try to look. One thing I will have you notice, if you never paid attention, when you pull up a Microsoft page, you'll notice you have these little green checks to what's supported. And I pulled up merge on purpose. Right now, Azure SQL Database does not support the merge command, which means you have to go the old-fashioned way of doing your own update or insert, depending on whether the information is there. So I don't know if I say, let's see if print is showing up here. It says it's supported.
Right.
So it's really important when, like I said, I used to have this one page that summarized what was not supported. It's no longer there. So this is really important to use this. There is also another page. My link will take you to this page, but there is a page here that talks about what is supported for tables in Azure Data Warehouse, and I've added that link to the slide deck. I thought this was the page, but maybe I went off of it. Any other questions?
Yeah, we got time, I think, for one last question.
Okay.
In consideration with Azure Data Warehouse, where is SSAS now in the big picture?
I actually cannot answer that question for you. I can look into that if you want, but I honestly think SSAS is a separate product. So is the question, are they getting rid of it? I think the answer is no. SSAS meets a different need, right? That's for doing analytics, whether you want cubes or tables. Azure Data Warehouse is really geared towards storing really large amounts of structured data and still being able to access it efficiently.
Right, and from what I recall, analysis services can use can use Azure Data Warehouse as a source, and so you're able to then put over your data warehouse the model that you want, whether it's local, within your environment, multidimensional and tabular, or if it's online, you can just use the tabular.
However, I would be cautious if you're trying to create SSAS cubes from Azure Data Warehouse. The data presumably is very large. If you put in an Azure Data Warehouse, you would want to keep your SSAS cubes to a small subset of that. Otherwise, my recommendation would be to use SSAS products to figure out what your metrics should be, and then once they've matured, create summary tables either in Azure Data Warehouse or in a Azure SQL database that has used Elastic Query to query Azure Data Warehouse. That's what I did for one of my clients. We created our data marts in Azure SQL database querying Azure Data Warehouse.
Right. Okay, great. Well, that is the time that we have available for today. Thank you, everyone, for attending, and thank you for all the questions that came in here at the end. With that, I'm going to close things up. And Beth,
I was just saying, thank you, everybody. Feel free to reach out if you need to.
All right. Thanks, everyone, and goodbye.